Hello YouTubers, hello. I've been messing around with this Radionics kit again, and this is experiment 25, and as you can see it is working. 4 transistors, 2 diodes, quite a few components, more than before. I've had to rub some of these out of the radio because I haven't got enough of certain parts. But yeah, that's working fine. This is experiment 25. It's the frequency divider. The circuit in this experiment consists of 2 multivator circuits joined together, TR1 and TR2, from a stable motivator to provide a series of time pulses at a fixed frequency. An explanation of this operation can be found in experiment 17, TR3 and 4, from a bistable moderator as used in experiment 22, 23 and 24. And that's the layout, and that's the circuit diagram for it. Yeah, pretty good, huh? Yeah, because when you're a youngster and you've been given this to play with, this was absolutely fascinating. Really was fascinating, you know. Yeah, very good. I'm going to do another YouTube, maybe, or maybe even part of this one, I don't know yet, showing you the best way to solder these contacts. As you probably noticed in the other ones that I've done, like the electrolytics, all 4 of these black ones, they're not original. These are new ones. You can't get the old ones anymore in good condition. I just getting a few. These are a few of the old ones that's come out. See, that's an even older one. My kit had something like these in the Phillips capacitors. Oh, I'm just having a look. Let's see what we've got. There's a whole load of them that's been ripped out. And you can see all these are bad. I just kept them for keepsake, really. But this experiment wouldn't work. Oh, that's gone off again. I think we've got a dodgy connector there. So, like I say, I'll show you how to do that. And there's a transistor that I've replaced the transistors on. It wasn't this type of transistor because I found some transistors that have been blown in these various bits and pieces that I've got. Yeah. So I'll show you that. This is the sort of thing that happens. I've tried to repair this the best I can. It was in an awful state when I got it. Been well and truly heated up with soldering iron and all the rest of it. I've tried to get it back into working order by using that hot glue, but it hasn't quite worked as well as I wanted it to, so we're probably replacing the whole thing with an actual pot, rather than bolt it into this circuit board. That's the only options that we've got, really. These weren't very good to start with, I don't think. You know, very ephemeral. So anyway, let's have another look and see what other experiments we can do instead of waffling on. Right, this is experiment 24, memory circuit with 1 switch. And I'm getting mixed results with this. I don't know if that's working right or not. It doesn't look like it's working properly to me. circuit's right. I checked it because I left this diode out. I think it's sort of working. Yeah, you've got to do it quickly. I think the idea is that one light goes on and the other one stays off, and alternately. Yeah, it's sort of working. I don't know what it says here. The circuit in this experiment is a refinement of those in the two preceding experiments. It is still a bistable circuit, but now only one switch is needed to switch from one state to another. When the battery is first connected, the circuit light either lamp... Oh, hang on, I've cocked that up, haven't I? Let's start again. When the battery is first connected to the circuit, either lamp may or on, but TR1 is always switched off. The only time that TR1 is switched on is when the switch is pressed. For the purpose of this explanation, it is assumed that lamp 1 lights when the battery is first connected, which means that TR2 is switched on and the collector voltage on TR2 is thus near zero, which means TR3 in the switched off state via the 1K resistor. That's the circuit there. I'll just move it out of the way. And that's the diagram for it. And it's the first time I made this, because I'd never actually made this circuit when I was a kid. I was more interested in the radios. Yeah, it's not... One lamp is staying lit a bit. I don't know if that's because these electrolytics are low ER ones, because that was the only ones I had at the time. Possibly, I don't know. But it's sort of working, isn't it? Yeah. Either that or we've got a leaky transistor somewhere. Wouldn't be at all surprised. Right, that's 2 experiments done. Let's have a look, see what we can do next. Well, so far this circuit doesn't seem to be working very well. I've checked it all and everything seems to be wired up correctly. I can't see anything wrong. Right, what this is this experiment 21, and it's basically an alarm system, supposed to be. And oh, hang on a minute, the lamp's gone out. Or maybe it might work, because when I put it on, the lamp would stay on. Let's try it. Yeah, it's working. Here we go. It is working. I didn't think it was working there. Right, okay. We have 2 transistors and working as switches, and it basically works off sound. And when it receives the sound, in other words, electrical signal through to here, it's amplified and turns the switch on, turning on the bulb. So I'm going to be quiet for a second, and hopefully, if I'm quiet enough, the light will go out. So let's see if that happens. There you go. And now I'm talking again. Yeah, I tap the microphone and the light comes on. It's working. It's gone out. That's clever, isn't it? That's clever. See, yeah. Yeah, there's the microphone. It's basically an earpiece, and it's my voice that's triggering it. You can see the light has gone out, but as soon as it hears my voice and picks up enough, on comes the light. I just tap this speaker here. See, it's an earphone acting as a speaker. There you go, and off goes the light. Right, it says here, this circuit demonstrates one application of the monostable flip-flop circuit described in experiment 17. In a normal state, the TR1 transistor is biased into conducting by its 470k resistor. Its collector is thus at 0 volts because its collector is directly coupled to the 1k resistor to the bias of TR2, to the base of TR2. The latter is cut off and the lamp is out. The earphone function is a microphone is coupled via the 100 UF capacitor between the base of TR1 and earth whilst into the microphone, or a slight tap will produce an alternate current in the emitter-based microphone circuit. This will be reflected by the emitter-based diode, resulting in a negative pulse on the base of TR1, switching it off. The TR1 collector voltage goes positive, thus via the 1k resistor switches TR2 on, lighting the lamp. And that's the experiment there. Good, isn't it? Yeah. Well, there you go. That's another one done. Don't worry, I'm not going to sing. I just wanted to show you this before I knocked off with this video. I didn't solder this, but this is what's happened to me with other components. You see, the thing is, you got this metal stud. You've got the thread on one end, as you can see. All the components are the same. I know you already know this. And you have a pin sticking up that you solder to. And the problem is, the minute you start soldering to this, you're heating up that plastic and it tries to shrink. Because it doesn't shrink as much as, well, the metal expands and the plastic shrinks, is what I'm trying to say. And it splits. I don't know if you can see that on camera. Can you see that crack? I didn't solder this particular component, like I said, but I did run into all kinds of problems with the others. They were splitting, the pins, these legs came together out of position, and it was just generally a right pain, is the only way of describing it. So the next opportunity I get, I'm going to show you the best way to replace these parts and solder onto these without damaging the plastic. Because the capacitors, I mean the ceramics, I mean, I usually use these mustard colour ones most of the time. I have seen others. They are usually pretty good. They usually stay on value. It's the electrolytics that go out of value. They go dry inside, and their values go all over the place, and don't hold on to a charge very long. And some of these experiments do need the component to hold on to some kind of a charge to make the circuit work. So the next opportunity I get, as I say, I'm going to show you the best way to solder these with a minimum amount of fuss where you don't damage your parts. Okay, anyway, this is it. I'm going to knock off now. Wish you all the best. Thanks for watching. More to come later. If you like what you see, it does mean a lot to me. Please subscribe. If you've got any comments, good or bad, I'll be interested to hear what you have to say. Thank you very much for watching. See you later. Bye bye.